Hello everyone, welcome again in Eng-Man YouTube channel. So we will continue our reservoir engineering playlist, and still the topic is still about recovery factors, benchmarking recovery factors. And today's topic is about new recovery correlations or recovery factor correlations for waterflood reservoir. All right, so here we go. So the materials presented in this video is taken from this paper, New Proxy Models for Predicting Oil Recovery Factor in Water-Flooded Heterogeneous Reservoirs. So you can find it in the internet. The paper is quite simple, easy to understand, and it's helpful. Okay. And if you read the paper, we have two new recovery factors correlations. The first one is recovery factor at breakthrough time. And you can see here, we have already two new correlations. Recovery factor at breakthrough, but in expanded form, this one, and then in simple form or reduced form, this one. Okay, but before that, the authors generate these correlations by first performing reservoir simulations. Okay, so they use a generic reservoir model, they perform reservoir simulations, and then they select 4 key parameters to be varied, and the parameters are water injection rate, and then reservoir heterogeneity, represented by this V, all right, Dijkstra-Parson parameter, okay, and then the viscosity, this one, and then permeability anisotropy, this vertical permeability divided by horizontal permeability. So we have 4 key parameters to be varied. All right, again, the first one is anisotropy, Kz per Kx, water viscosity, and then reservoir heterogeneity represented by Dijkstra-Parson parameter, and then water injection rate. Okay, so they use a generic reservoir model, and then they perform reservoir simulations by varying these 4 parameters, and then they make hundreds of scenarios of runs, and from those results, they came up with these correlations, the expanded form, and then the reduced or simple form. Okay, so basically, if you read the paper, first, the simplest thing that you can do is you can use this correlation, all right, to predict the recovery factor at breakthrough time. You can either use the expanded form, and you can also use the reduced form, and then you can compare the results between two of them. All right, so it's very handy, it's very easy, although the correlations are quite long, but you can see it's actually straightforward and simple. As long as you have the permeability anisotropy, viscosity of water, and then you know the Dijkstra-Parson correlation or the Dijkstra-Parson parameters out of your reservoir model, you can extract the V from your model, from your reservoir, and then you get the water injection rate. Okay, you must know the water injection rate, of course, and then you can calculate, you can predict the recovery factor using these relatively straightforward correlations. And then, of course, the most important thing is the recovery factor at the end of waterflood. Again, we have new correlations in expanded form, and then reduced or simple form. Okay, so again, they use generic reservoir model. They perform hundreds of reservoir simulations by varying 4 key parameters, as I said before. And from those results, they performed statistical analysis to come up with these correlations. And then, of course, they do comparison between the simulated and the predicted, okay? And the result is quite good. So you can, again, you can read this paper. Okay, so you can use empirical correlations like Guthrie correlation and then API or ARPS correlation to predict your recovery factor. You can also refer to these new advanced models or correlations. But of course, just like other correlations, of course, this modeling, this correlation also has restrictions, limitations, which are very related to the assumption that they used, the generic model that they used. Okay, so you can use these new correlations, but still be aware with any restriction, weakness, and limitations. But of course, you can use this for comparative purpose, for comparison purpose of the recovery factor benchmarking. Okay, so lastly, these are the 4 variables. These are the 4 parameters to be varied in their simulation, in their study. So reservoir heterogeneity, represented by V or the extra Parson parameter of 0.1, 0.3, 0.5, and 0.7, and then water injection rate, 2,000, 5,000, and 10,000 stock time barrel per day. Permeability anisotropy, vertical axis divided by horizontal axis, 0.1, 0.3, 0.5, and then 1, okay, homogeneous. And lastly, water viscosity, 0.25, 0.5, 0.75, and 1 centipoise. And then from the statistical analysis, they compare all of these, parameters. We can see that the most important parameters, you can see from the percentage contribution, the most important parameter is, of course, the water injection rate. Okay, not of course, by the way, this is the thing that they conclude from their study. Okay, we can take note from this, and they conclude that water injection rate is the most important parameter that will govern the recovery factor. That's a very important thing to note. And then the second rank is, from this you can check the reservoir heterogeneity. So water injection rate is very important, will control your recovery factor, but don't forget reservoir heterogeneity also play a very important role in determining your recovery factor. And then after that, basically the square of water injection rate, but it's not the basic parameter, it's derivative parameter, okay? So if you consider only the basic parameter, then the third most important thing is the anisotropy. Okay, it's also very important. Okay, the anisotropy between the vertical and permeability, vertical and horizontal permeability. And the least important parameter is the water viscosity. It still has contribution of 2.3%. Okay, and as you can see, other parameters here are just derivative. Square and then power by 3 and then multiplied among the parameters. But the key, the basic, the core parameters are these top 4: anisotropy, viscosity, reservoir heterogeneity, and water injection rate. If you read, again, if you read the paper, the authors also see that their models and their correlation had, limitations, restrictions. So you need to be aware with the limitation that it has if you want to apply these correlations. Okay, but I think, in my opinion, you can still safely use these correlations as benchmarking purpose. Of course, you need to compare it with the results from other approaches, other methods, other empirical correlations. Okay, so I think that's it. So it's a very good thing for us to have new correlations to predict the recovery factor. Okay, so again, thank you so much for watching. I hope this video is useful. I hope this video is informative for all of us. Thank you so much, and see you again in the next reservoir engineering playlist in this channel. Thank you.